Hi guys, so today we're going to be talking about similar polygons, and before we get started with our example questions, let's define what a similar polygon is. So a similar polygon are polygons that have the same shape but may be different in size. Okay? And what we know about two polygons that are similar is that they are similar if and only if their corresponding angles are congruent, so angles are congruent, and the measures of their corresponding sides are proportional. Okay. So the difference between similar polygons and congruent polygons is for congruent polygons, both the angles and the sides are congruent, but for similar polygons, the angles have to be congruent, but the sides are proportional. Okay. And this is the symbol that we use for similar. It's read as similar to. Right? And so this is an example of similar polygons, right? Because every side on this is half of the original. Okay? However, the angles are exactly the same. They're congruent. Okay, so let's get started with example 1. We're going to determine whether the pair of triangles here is similar. So what we're going to do is we're first going to match corresponding sides, or what is most likely the corresponding side. Right? So the best way to do that is by length. Right? So here the longest length is 12. So if they are similar, it should correspond to the longest length here, which is 9. Then the shortest side here is 6, and that would correspond to the shortest side here, which is 4.5. Okay. And so then the medium side would be this and this. Okay. So we're going to see if this is proportional, if the sides are proportional. Okay. So we're going to match pink with pink. So longest side, 12/9. We want to know, is it proportional? Yeah. So since I chose this one to be on top, right, and this one to be on bottom, I need to stay consistent. So this 6 will be on top, and its corresponding side, we think, would be the 4.5. Right? And then this 6 square root of 3, okay, and 4.5 square root of 3. Okay. Okay, so again, which one's on top and bottom doesn't really matter. However, right, you have to stay consistent. So whichever one you pick first to be top or bottom doesn't matter, but after that you need to stay consistent, right? So note that all of the measurements for this triangle are here on top, and all the measurements of this triangle are here on the bottom. Okay, so here I know that this and this is already proportional because the only difference is multiplied by square root of 3, multiplied by square root of 3, you get this. Okay, and then 12/9, how to know if that's proportional? If I do 12 divided by 9, I get 1.33323, and if I do 6 divided by 4.5, I get the exact same number, right? So these are all equal, meaning they're proportional. So, because corresponding angles are congruent, right? We know that from the 90 degrees, the 30 degrees, and then this would be the 60 degrees. So corresponding angles are congruent. And because corresponding sides are proportional, right, this is a true statement. The ratios are equal, which makes them proportional. Then we know that they are similar. Okay. So why don't you try CYP1A, and then once you're done, come check your answer. Okay, so you should have gotten not similar, because even though the corresponding angles are congruent, right, 90, 90, 90, 90, 90, 90, 90, 90, the corresponding sides are not proportional, right? Because the pink sides, the 7/6 here, is not equal to the blue sides, which is 6/5. Okay? It's because it's not proportional, not congruent, not similar. Okay, the next one here is example 2. So this is a miniature replica of a 1923 checker cap. The length of the model is 6.5 inches long. If the length of the car is 13 feet, we want to know what the scale factor of the model is compared to the car. Okay? And so what a scale factor is that when you compare the lengths of corresponding sides of similar figures, that numerical ratio is the scale factor. So right now, that model car, we want to know what it is for the model compared to the car. Okay. So here, as you can see, this is in inches, but this is in feet. So the first thing we need to do is change it so that way it's the same units. So we're going to change this 13 feet into inches. So 13 feet, in 1 foot, there is 12 inches. And then the feet cancel, leaving you with just inches. 13 times 12 is 156. And then 1 times 1 is just 1. 156 divided by 1 is 156. So 156 inches. So the model is 6.5 inches to the car's 156 inches. Okay, so this is the ratio. And then we rewrite it as a fraction. This simplifies to 1 over 24. And so the scale factor is 1/24. And there we go. Okay, so why don't you try CYP2, and once you're done, come check your answer. Okay, you should have gotten that the scale factor is 1 over 72 or 1 to 72. If you got that right, you can move on to example 3. If not, here's your explanation. Okay. So we know that the height of the actual monument is 60 feet and the model is 10 inches. So here we're comparing the model to the original. So model to the original. Because one is in inches and the other one is in feet, we need to change them into the same units. So I'm going to change the feet into inches. So 60 feet and 1 feet, there's 12 inches. So 60 times 12 is 720. So the model is 10 inches and the original is 720 inches. So then written 10 over 720. If I simplify that, I get 1 over 72. Okay? And then this is another way we can write that ratio or scale factor. Okay, now let's move on to example 3. So example 3, it tells us that these two polygons are similar. Okay, and so here we want to write a similarity statement. Okay? Then we want to find x, y, and ut, and then later we want to find that scale factor. Okay? So the first thing I'm going to do is I'm going to match up corresponding parts, okay, which is pretty easy because it's not rotated or anything, right? So 2 arcs to 1 arc, that is this. So, yeah. This is 1 arc to, I think, 5 arcs. That's this. And, this is with this, but so I'm not going to mark it. So this to this. And this to this. Okay. So first we're going to write a similarity statement to say that they're congruent. So what I'm going to say is polygon. I'm going to name it. Okay. And how we name a polygon is we pick a vertex, and then we go either clockwise or counterclockwise. Okay. So I'm going to go pick R, and I'm going to go counterclockwise. So this is polygon RSTUV. So how you name the first one doesn't matter, but afterwards, the other one needs to match up with corresponding parts. So this is the symbol for similar. So polygon RSTUV is similar to polygon. Okay. So matching corresponding parts, R corresponds to A, and then going around this way, because this corresponds to this. This is A, B, C, D, E. Okay. So that's my similarity statement. Okay. Now I want to find x. Okay, so x is here. Okay. So to set my proportion, I'm going to find the ratio that is completed. So that's this blue side here. Okay. So I'm going to do 18 to 4 equals to Right? And then since I chose polygon RSTUV to be the one on top, right, the big one on top, small ones on bottom, I need to stay consistent. So the X is part of the bigger polygon, so that'll be on top, and then the smaller polygon 3. Okay? Then to solve a proportion, we cross multiply. So 4 times x is 4x, and then 18 times 3. 18 times 3 is 54. And then divided by 4, this is x is 13.5. Right? Then it wants me to find y. Okay, so again, I'm going to use the sides that are completed for both as my ratio. So 18 over 4 equals, and then for y, it'll be y plus 2 over 5. So again, staying consistent, if I chose the bigger one to be on top, the bigger one has to be on the bottom as well. Then I'm going to cross multiply, so 4 times y plus 2 equals 18 times 5. Okay. Distribute this becomes 4y plus 8. 18 times 5 is 90. Subtract 8 on both sides, this is 4y equals 82. Divide by 4 on both sides, y equals 20.5. Okay. And then it asked me to find ut. So ut I know is y plus 2. Here's ut, it's y plus 2. Now that I know that y is 20.5, I can plug that back in. So ut is 22.5, and then the units is meters, so that's meters. There you go. So similarity statement, x, y, and ut. Okay. Then it asked me to find the scale factor of polygon RSTUV to polygon ABCDE. So I'm going to use my completed side that was given to me. So RSTUV goes on top, the 18. ABCDE goes on the bottom, 4. 18 over 4 simplifies to 9 over 2. Or if you don't want to write it as a fraction, you can write it as 9 colon 2. And there you go. Okay, so why don't you try CYP3, and once you're done, come check the answer. Okay, you should have gotten this as your similarity statement. Triangle JKL is similar to triangle XYZ, or something that corresponds to that. Just remember J corresponds with X, K corresponds with Y, and L corresponds with Z. So the order has to match up. Okay? And then for A, you should have gotten 2.25. And the scale factor is 3 over 2 or 3 to 2, whether you write it as a fraction or as a ratio like this. Okay? So here, if you didn't get A equals 2.25, so I'm matching it up. So 3 corresponds to 2, right? Equals, okay, since it's proportional, then from the big one, since the big was on top, then A goes on top as well, and that corresponds to the 1.5. Cross multiply, so 2 times A is 2A, 3 times 1.5 is at 4.5, divide by 2 on both sides, you get 2.25. Okay, the next one is example 4. So triangle ABC is similar to triangle XYZ, and it has scale factor of 2 to 3, or 2/3. If the sides of triangle ABC are 6, 8, and 10 inches, what are the lengths of the sides of triangle XYZ? Okay. So basically, with the scale factor, I know that triangle ABC is on top, triangle XYZ is on bottom. Okay. And so 2 over 3 equals, okay, so since I know ABC is 6 and ABC is on top, the 6 is going to go here, and I'll put that as Y. Okay. To find the other one, corresponding one, so 2/3 again. 8 is from ABC, so that's on top, 8 over Y. And then 2/3 equals, and then 10 here over Z. Okay. So cross multiply, 2x equals 3 times 6. 2x equals 18, so x equals 9. So one of them is 9 inches. Cross multiply, 2 times y is 8 times 3. 8 times 3 is 24. Divide by 2 on both sides, y equals 12, so the other side is 12 inches. And then 2 times z is 2z, 3 times 10 is 30. Divide by 2 on both sides, the last side is 15 inches. There you go. So why don't you try CYP6, and then once you're done, come check your answer. Okay, you should have gotten that the lengths of the sides of rectangle JKLM are 6.25 centimeters and 15 centimeters. If you got that right, you can move on to example 5. If not, here is your explanation. So we know that the scale factor for QRST to JKLM is 4 over 5, or 4/5. We know that the lengths of the sides of rectangle QRST are 5 centimeters and 12 centimeters, which is why you see it on top of here and here for our proportion, because that 4 corresponded with the QRST. Right. So then I put my unknowns on the bottom. Cross multiply here, 4x, 5 times 5 is 25. Divide by 4 on both sides, you get 6.25. Cross multiply to find the other one, 4 times y, 5 times 12 is 60. Divide by 4 on both sides, you get 15. So that's why the sides of the rectangle are 6.25 centimeters and 15 centimeters. Okay, so then our last is example 5. So the scale on the map of New Mexico here is 2 centimeters is 160 miles. The width of New Mexico through Albuquerque on the map is 4.1 centimeters. We want to know how long would it take to drive across New Mexico if you drove at an average of 60 miles per hour. Okay. So before we can find how long it takes, before we can find out the time, we first need to find out what the actual distance is for New Mexico, the distance or the width of New Mexico through Albuquerque. Okay. So here we're going to do centimeters to miles, also known as our map length compared to our reality. Okay. So we know on the map 2 centimeters is 160 miles. Okay. So if on the map it is 4.1 centimeters, we are trying to figure out what it actually is in miles. Okay. Yeah. So then we're going to cross multiply. 2 times x equals 160 times 4.1. 160 times 4.1 is 656. And then divide by 2 on both sides, x equals 323. So in reality, the width of New Mexico through Albuquerque is 323 miles. Okay. Now we want to find how long it would take to drive across New Mexico if we drove at an average of 60 miles per hour. So this is a distance equals rate times time problem. So distance is rate times time. So distance is 323 miles. The rate right now is 60 miles per hour. And then we're trying to figure out what the time is. Okay. So we're going to divide by 60 miles per hour. Okay. And 323 divided by 60 is about 5 7/15. So it would take 5 7/15 of an hour, or if we want it in hours and minutes, it's 5 hours and 28 minutes to drive across. There you go. Okay, so why don't you try CYP5, and then once you're done, come check your answer. Okay, you should have gotten 2 34/55 of an hour, or 2 hours and 37 minutes. If you got that right, you can get started on your homework. If not, here is your explanation. Okay, so remember that the scale on the map is 2 centimeters is 160 miles. Okay. So if we know the distance on the map from Las Cruces to Roswell is 1.8 centimeters, right, we can put that on the top, where this is the map, and then this is the reality. Okay, then cross multiply, 2 times x is 2x, 160 times 1.8 is 288, divide by 2 on both sides, x equals 144, so the real distance is 144 miles. Then, if we want to know how long it takes to drive there, distance equals rate times time. So 144 is the distance. The rate is 55 miles per hour. Time, divide by the rate. You get this. And then in terms of hours and minutes, it's 2 hours and 37 minutes. So that's it for today. Have a great rest of the day. Bye, guys.